are going to discuss now the different derivatives formula for the sum, differences, product, and quotients. Let me give you first the derivative of the sum. So given that you have, let's say, for example, you have y is equals to u plus v, wherein u is any function of x, and v is any other function of x, then we are going to let x to increase to x plus dx, and y will increase to y plus dy, and therefore u will increase to u plus du, and v will increase to v plus du. So if you are going to write down y plus dy is equals to u plus du plus v shall be increased by dv. So the rules that we are going to tackle is the sum rule. Okay. So this is our sum rule. And that by subtracting from the original, I mean u plus ub, if you are going to subtract y is equals to u plus v, okay, we will have dy is equals to du plus dv. So this is the original equation, y is equals to u plus v, wherein u is function of x and v is any other function of x. So we are going to increase y to y plus dy, and u to u plus du, and v shall be increased to v plus dv. So therefore, if we are going to subtract the original equation, y is equals to u plus v from this equation, then what remains to us is dy is equals to du plus dv. And then if you are going to divide both sides of the equation with dx, you are going to divide both sides of the equation with dx, then dy dx is equals to du over dx plus dv over dx. So therefore, this justifies the procedure. And you differentiate its function separately, add the results. So this will be our formula for the y plus v, y is equals to u plus v. So if you are given an example, so if we are given an example, let's say y is equals to x squared plus c plus you have a x to the fourth plus b, and you would want to determine dy dx. That is simply equals to the derivative of x squared, which is 2x. Derivative of the constant is 0, plus derivative of ax to the fourth is 4 times a times x raised to the third power, plus the derivative of constant, which is equals to 0. So that means if you would like to determine the derivative of y given in this example, then the value of dy dx is equals to 2x plus 4ax cubed. So if we are going to make use of this formula, given this derived formula for dy over dx, all we have to do is to determine, okay, so dy dx will now become dy dx will now become the ddx of u plus the ddx of v. So this would become d dx of u plus d dx of v. So if we are going to let u to be x squared plus c, so we are going to let u is equals to x squared plus c, and then b is equals to ax to the fourth plus b. Then using this dy over dx, then we will have the ddx of x squared plus c plus the ddx of ax to the fourth plus b. And that would give us with the same value for dy over dx, which is equals to the derivative of x squared is 2x, the ddx of c, which is equals to 0 because that is a constant, then plus the ddx of ax to the fourth, which is equals to 4ax cubed. So that is dy over dx. And you would notice we've got the same value here. We've got the same value, dy over dx. So exactly as before, if there were three functions of x, then you can do so. To just add, let's say, y is equals to u plus b plus w, just add, and the same procedure, you're going to use the same procedures.